Okay. Yeah, who am I? Andreas Hussong, you already mentioned that. I'm living in Aachen in Germany, working for Philips, currently in the role of a tech lead in advanced development. And in that role, um, me and my team were recently asked to look into a certain problem that we are having. And the task is that we want to increase productivity in some of our existing applications. And basically by adding clinical decision support functionality to these existing legacy applications that we have. The main problem that we are facing with that is that those legacy systems typically do not support FHIR. They're not FHIR enabled. There is no FHIR interface in these applications. And there's typically also no FHIR server anywhere in the play. So that's the main problem that we need to address. To quickly explain what exactly we want to achieve, I have a few examples for the 3 use cases that we want to support. Very simplified example, first of all, rule-based creation of findings based on existing data that we have in a system. So for example, to calculate a body mass index based on a patient's height and weight measurement, classify the obesity of a patient based on this BMI value, would be a classical example for that. Secondly, we want to support completeness check. So we want to be able to check if the data in our system for a certain patient is complete, if all the data items that we expect to be there are actually present. So leveraging the same example, for example, to check if the height and the weight measurement are actually there. And last but not least, we want to support consistency checks, which means we want to verify if all the data that we have in the system is consistent and there are no conflicts between data items. So assuming you would have a manually entered BMI value, to double check if that is actually supported by the underlying weight and height measurements, or if there is a conflict or something went wrong when entering that value manually. We have some basic requirements. First of all, as I said, we want to integrate with multiple different Philips products. We want to support or need to support non-FHIR proprietary data formats in these applications. We want to build something that's lightweight and independent and can be hosted or deployed next to the existing application, so no deep integration. We want to support different deployment scenarios, so both cloud as well as an on-premise deployment should be possible. And last but not least, it should be fairly straightforward and easy to create new rules for this clinical decision support system. Ideally, it should also be possible that a non-technical person can at least review those rules. So a subject matter expert, for example. And last but not least, we want to enable automated testing of the rules because we're software engineers. All this led to a few architectural decisions that we took. First of all, we want to build on top of established technologies. For data that's FHIR, for the rule language, we decided for CQL. And for the API or interface to our system, we want to go with wanted to go with CDS hooks. From a technical perspective, we want to build some modular microservice architecture system and want to go with a containerized deployment. Yeah, this is the main overview of what we actually built. On the left-hand side, you see here the application that we want to integrate with. The light blue box is basically, the light blue box here is basically the whole system. And as you can see, we have multiple microservices here, starting with the facade that handles our translation from the proprietary data formats into CDS hooks and the embedded FHIR resources. Then we have a CDS service provider that exposes the CDS hooks API. And in the end, we have a CQL execution service that can execute our CQL and return the results back to the service and then back into the final into the hosting application. I will now go one by one over these different services, but let me start to show you quickly the CQL toolchain that we built to transform the CQL into something that is actually executable. As you can see, we are currently using the Java toolchain here to translate the CQL into Elm. And for all subsequent steps, we are using the CQL.NET SDK, so translating the Elm into C# code. Into C# code, and then compiling that C# code into a .NET assembly. And last but not least, packaging all these items into a FHIR library resource that we can then hand over to, for example, our CQL execution service. I have a quick, demo is probably too much, but let's see, I can quickly show you how the CQL that we are building looks like. This is a very simple example that you saw before about the obesity. So here we have some statements where we extract the height and the weight from some fire observations using a library that we created to simplify that step. We are calculating here the body mass index from these two measurements. Then we have some classification of the obesity based on the BMI value that we calculated. And last but not least, we are creating the cards and system actions that we are then returning. That's basically the data format of the CDS-Hooks that the CDS-Hook specification defines. And as you can see, we are currently using tuples here to construct these complex objects. And if we run this through our pipeline, what we end up with is, as I said, a file library resource here. This has some metadata like the name and the version, so it's a versioned item. That's pretty nice. We have some dependencies defined here, and last but not least, but most importantly for us, we have the content section, and inside of that content section, you can find the original CQL. That's base64 encoded in this string here. We find the Elm, and most importantly for us, the .NET assembly, and that's basically what we then extract and execute. Speaking about execution, to execute that CQL, we built a CQL execution service. That's how we call it. It's basically a standalone microservice that has a REST API here where you can upload these library resource files. We store them in a database, and then we have a execution endpoint here where we can send data to and a list of rules that we want to execute on that data, and then get the respective results back. And that brings me to my next quick demo. So I have this service running locally here. Let me see, on a Docker container here on localhost for port 4080. Let me quickly check if I have all the resources that I expect actually there. Yes, I have the obesity rule that I showed before, plus the dependencies uploaded here, and I can send now a post request to our service to execute some data. And let me show you how the payload actually looks like here. Probably close this here. This is the data that we're sending to the service. As you can see, there's a file bundle here with some resources. Here's a patient, and there's an observation for the height, and there's an observation for the weight. And last but not least, we are sending the rules or list of rules. In this case, it's one, it could be multiple, that we want to execute on this data set. And if I now execute this request, yes, it worked. This is what we get back. First of all, some information which rules were executed, an indicator that it was successful, and the last but not least, you can already pin here the well-known CDS-Hooks format to the cards, and somewhere in here is also the system actions. So that's basically what this CQL execution service returns. That brings me to the next service, our CDS service provider. Very similar setup, again, standalone microservice. We have a REST API here where we can upload service definitions or configurations. This configuration is basically the mapping of a CDS service name or ID to a list of rules that we want to execute for that specific service. And then we have here the CDS-Hooks API execute endpoint again, where we can send data to. We are sending the data directly in the prefetch field. I will show that in a second. And then basically this service under the hood calls the CQL execution service to get the results back and returns then the cards and actions that it extracts and aggregates probably over multiple rules. So if you have multiple rules in one CDS service definition, they will be aggregated into one set of cards and actions. And also for this, I have a small demo, sorry for that. So let me see. Close this. Also this service is currently running as a Docker container locally on my system here. Let me quickly check. I have one service currently configured here, which is the obesity decision support service. And yeah, a quick look at the payload that we're sending. Again, we have the patient and the respective operations here, and that's what we're basically sending to the service here. And let me execute that as well, and then you'll see the cards and system actions. The cards basically here with some information that can be displayed in a UI, and the system action to create the missing BMI observation that we didn't find because we just had to wait in the height measurement. Yeah, and last but not least, the facade service that basically handles the translation from these proprietary data formats that we find in our applications into FHIR, wraps them in the CDS hooks call, and on the response also extracts the FHIR data from the cards or the actions and translates them back into something that our applications can handle. Yeah, and that, again, is the complete system that we saw before. Yeah. Quick summary, we successfully implemented this as a proof of concept for one of our applications, and we were able to show that we can add rule-based clinical decision support functionality to an existing application with this, even if the existing application does not yet support FHIR. Some conclusions or learnings that we made while we implemented that. First of all, we see that CQL fully meets our needs. We were able to express all the rules for all the use cases that we had in mind, so that's pretty nice. I briefly showed that we're currently using these tuples to construct the cards and actions in the CQL directly. That's something we actually don't really like and we would like to change. So if anyone here is interested to team up and create some proper model for these objects in CQL, so a model definition file, please reach out to me. Happy to join forces on that. Then for the CDS hooks stuff, similar situation, fully supports all of our needs, the different response formats that it provides, so the cards for something that's supposed to be shown in a UI, or the actions that allow data manipulations. Yeah, that's basically, we can build all of our use cases with that. And last but not least, there's even a way that you can embed an action in a card via the recommendations, and then you can build some user approval flow around that as well. The nice thing for our modularization is that we can reuse our services even for different use cases now. So the CDS service provider, we cannot only use it as a front end to our rule-based CQL execution service, we are now experimenting also to use it as a front end to add AI functionality to our applications. And the other way around, we are also experimenting currently to reuse our CQL execution service in the context of calculating CQL expressions to populate FHIR questionnaires. So it paid off that we created two separate services here. And last but not least, the CQL.NET SDK also met most of our needs. We use it in the toolchain that I showed to create the FHIR library resources and package that. It's the technology that powers the CQL execution service under the hood. And yeah, the CQL to Elm transformation also gained some traction recently, and we hope that we can also use that and get fully away from the Java pipeline. And yeah, I don't want to, yeah, we are .NET shop, sorry. Yeah, big thanks to the creators, so NCQA, and also the current maintainers of the CQL.NET SDK, namely Paul here. So Firely, yeah, that's basically what enabled us to do or to perform this experiment. Yeah, my contact, so if you have any questions, please feel free to reach out to me via email, Zulip or Wuber. And I think that was my last slide. Yeah.
Thank you, Andreas. Perfect timing. German timing.
My first run was at 30 minutes. So,
so is there any question for Andreas? Yes.
One of the problems I faced when implementing CDS is which rules to run, which specific rules to run in any case. So you are doing that based on which service you are calling,
yes,
and you will group the rules for that. But yes, the sender needs to know which rules he wants to, which universe of rules wants to apply.
Yes. Yeah, that's one thing that we're also facing, especially we want to build something that's probably a multi-tenant system, and we might want to run different rules for different tenants probably. So we're also experimenting here that we might also, based on the tenant or the user of the system, select the rules. Yeah, but that's something we're currently experimenting with. But exactly, that's a small problem.
Thank you.
There's another question here.
Thank you. It's good to see a nice, neat architecture like that having been proved in practice. What I was wondering about was what were the limitations that you found due to having to be working through a facade back into your proprietary data format? Because of the BMI example, obviously very simple.
Yes.
You're going to be able to get height and weight anywhere. But where do the limitations come in? Where does that start getting difficult?
To be honest, for now we haven't found any limitations. So as I said, we can basically map everything that we want. Might come up in the future probably for another application where there's different internal data formats. But for now, it was a simple mapping basically. We basically wrap all the measurements that we get in the system as a fire observation, and then on the way back, similarly. Yeah. Yes.
Great presentation. Coming back to your data completeness check and data consistency check, do you have any explicit pipeline additionally to consider if you are supplementing your data? Like you have the primary sources in FHIR conformed, but the secondary sources where you do not have it in FHIR format. Do you have any of those scenarios where you are integrating and publishing, or it's all handled in the facade?
I'm not sure if I fully get the question. So currently we're handling that fully in the facade, the translation, and then what we basically want to check is basically findings, so kind of diagnosis or like this BMI value against data, or if we have probably mutually exclusive findings, probably stating, I don't know, simple example, if a patient is male, then he can't be pregnant. That would be a simple example to double check these kind of conflicting informations. So that's what we're currently targeting, and that works pretty nicely.
And do you experience any data leakage as part of this pipeline, like as you are publishing, like any rejection or leakage due to the qualities?
No.
Thank you.
We still have time for questions, but I don't see any. So I will check on Wova. Check before, there were none, still none. So I think we can call it to the end. So don't forget, you can provide feedback. It's always welcome. Otherwise,
Feel free to reach
see you
out.
later.
Okay.